Okay, so for question one, we're generating a star here made up of 5 different colors. There's a gradients effect applied. So, we have the 4 vertices of the square are all yellow, and the 4 vertices of the triangles are different colors, but, they're blending. The reason for this is the program is automatically implementing interpolation. So as we go from one vertex to another, the colors between them kind of merge depending on the distance between them. Now in question 2, we can actually get around this interpolation, and how we do this is basically making 5 separate shapes that make up the star. So we have the center square that's all yellow, and then we make 4 distinct triangles surrounding it. So we have 5 distinct colors. In this case, even though the reason we're duplicating some of these vertices, because the triangles and the squares share some of these vertices, each vertex can only hold on to one color value, so that's why we need to make multiple copies to make these distinct colors. And then question 3, we generate this triangle with the 3 colors of gradients. The point of this assignment, though, is to switch the positioning of the colors and the vector positions. So we have to do this in several places. We do this in the simple vertex structure that we create. We also do this in the vertex data and the pixel data that's passed through. And then we also have to change the semantic order in the input layout as well. Just the semantic order, because specifically the 5th value in these arrays, the byte offset, needs to stay the same. So the information that's processed in the buffer will be processed in the correct order. So like this color will start at position 0, and then position will be a little bit at this fixed value that's after color, so it's processed in the right order. And then question 4 required us to have 2 different colors making up the star, so when we click the screen, the 2 different colors would change. Unfortunately, I wasn't able to get this working correctly, so it is only processing 1 color at a time, but I have also removed memory leaking from there, so it works. So at least that works. And specifically how this process works, it's using constant buffers and shader constants. So constant buffers are held on the CPU instead of the GPU. This allows information to be passed through them on the fly, so they don't have to be rendered all over again on the GPU. So in this case, the color value is being held on the shader constant, which when we click on the screen, it's passed into that constant buffer, and it is allowed to be able to change the color on the fly. And then we also had this other instance of this triangle where we were attempting to create kind of a white ring around the triangle the further away we got from the center. But instead, there's kind of a white color being applied to each of these vertices. Basically, just taking a look here, taking a look at this last line, it seems that for each vertex, we take its color value, which again is a 4-float vector, but we're adding on to that this value of d, the length of the position of the vertex, the length between the position and the center, and multiplying it by this float 4. So it essentially looks like we're just changing the color values of the actual vertices and not the area around the triangle.